Hello everyone. So today we are going to study the next topic of the chapter 1, states of matter. So here let's talk about, today I'm going to cover 2 points, states of matter and the classification of matter. So states of matter, we all know that matter can exist in 3 different states that we've already started in the lower classes. The first one is the solid state, the liquid state and the gaseous states. So these are the 3 states of matter. And naturally the constituent particles in solid state, liquid state and gaseous states are arranged in a different way, and that is why their properties are also different. So why water is different in the form of ice and it is different in the form of water and it is different in the form of steam is because the arrangement of water molecules is different in all the 3 states. Now the arrangement, how are they arranged? So particles are held very close in the case of solid state, and there is hardly any space between them to move around. So if we talk about the solid state, let's take this example. We can see that the molecule, the atoms or the constituents are very closely packed. For example, if it is a copper solid, then all the copper atoms are so closely sticking to each other that there's hardly any room for their movement, or there is no freedom of movement, and these particles are just moving around at their own position. So they're just oscillating. These atoms are just oscillating towards the left and the right, but they cannot move around other than this fashion. Now in the case of liquids, if we see the liquids, definitely the particles will be slightly more openly spaced, and there will be freedom of movement, and because of which we will say that they have a variable shape, because if we just put them in a container, the liquid will start occupying the shape of the container. But if the same thing we talk about solids will not occupy the shape of the container in which they are placed, but rather they will have a unique and definite shape of their own. So this was the particle distance. Interparticle distance in solids is very small. It's very small. In liquid it's little more, and in the gaseous state the particles are very far away from each other. As a result, they have a lot of freedom of movement. And let's talk about the properties of solid, liquid and gas in short. So this table will help you to understand that in solid the volume is fixed, the shape is fixed, whereas in the case of liquids, these you can say the volume is fixed whereas the shape is not fixed. Whereas in gases, neither the volume nor the shape is fixed. So what example can we give here, like which we all can understand? Like I have a cube, right? So cube is going to have a definite shape, that is cubical, and it has a definite volume. Let's say it has a 1 centimeter dimension, length, breadth and height. So its volume is going to be fixed, that is 1 centimeter cube. Even if you place this cube in another container, in a beaker, sugar crystal, let's imagine that this is a crystal of any solid like sugar, for example. Okay, so if you place it in a container like this, do you think its shape is going to change from cube to cuboid or to spherical or to something else? Absolutely no. So it's fixed, its volume is fixed and also its shape is fixed. On the other hand, if we take water and we try to pour water in a beaker, it's going to take up the shape of the beaker, right? So it's going to look like a cylindrical shape. If you put it in a conical flask, the water will appear conical in shape, right? So the shape of the liquid is not fixed, but its volume is fixed. So if you poured 200 milliliters of water in this beaker, the same volume is going to be also there in the conical flask. It's not going to change, it is fixed. Now let's come to the example of a gas. If you talk about gases, in the case of gas, what do you say? What's going to happen if you take gas? So for that, we'll take example like you have a container which is squarish in shape, and you put 1 liter of gas in this, 1 liter of carbon dioxide in this. So naturally all the gaseous molecules of carbon dioxide are going to occupy the whole volume of this container, and the shape of the gaseous molecule looks like a square. Same thing if you take it in a circular container, the container which looks like a circle, so definitely the shape will look like that. Let's assume that we are going to take it in a cylindrical container now. So if we take this in a cylindrical container whose capacity is 5 liters and the same amount of gas, that is 1 liter of carbon dioxide, if you put it in this 5 liters of container, and of course there's a lid on this, so what will be the volume of the gas? The volume of the gas is going to be 5 liters, because the volume of the gas is the volume of the container in which it is confined. So here we have understood two important points. This is important for you, that solids have everything definite, the shape is definite, the volume is definite. Liquids have a volume definite, but the shape is indefinite. Gases have indefinite shape as well as volume, and this pictorial representation of this has been shown in the book. You can see solids, the constituents are fixed. Liquids, the constituents have some space between the particles. Gases have lot of space. Naturally, in the case of gas, if you compress the gas, they will be easily getting compressed because there's a lot of space between the molecules, so they are highly compressible. Liquids, very little space, so they are slightly compressible. Solids, they have almost zero intermolecular space or interparticle space, so they are very rigid and almost incompressible. So now can you convert the solid state into liquid and the gas liquid into a gas? Of course you can. So how to carry out the conversions of states? So the answer to that question is that by changing the temperature and pressure. For example, if we take ice and we heat it, the temperature is increased, then it changes to liquid, and liquid, when it is heated further, it changes into gas. That process, solid to liquid, will be called as melting, and liquid to gas is called as evaporation or vaporization, we can say. And gas, you're condensing to liquid, and liquid you're condensing to solid. So how are you doing this condensation process? Of course by cooling. That means if we cool the gas in a refrigerator, it can become a liquid. Similarly, if we cool the liquid in a refrigerator, it can become a solid, and so on. So this is quite simple, and that's the first topics, states of matter. We have understood what are they, why are they different, because their constituents are differently arranged, and so on. Let's now talk about the classification of matter. So here we'll just go to this lovely flowchart which has been given in the NCERT textbook. Please refer to this, and when questions are asked, you can draw this beautiful diagram. So here we can see that the matter is, what is matter first of all? So matter is something which has mass and it occupies space. So two things which you need to talk about. Matter is something which has mass, number one, and also it occupies space. So these are the two things. So this is the first one, and this is the second one. So the matter which is there existing on the earth, that means everything which you see around you, including yourself, everything which you can touch, feel, sense, etc., etc., they're all matter. So matter can be divided into two types. Number one is mixtures, and the next one is pure substances. Now mixtures are having the substances which have got a variable composition, and the various components, as you can see here, I've written here components. So mixtures contain components. That means if you have got substance A and substance B mixed together, that is called a mixture. So like for example, I'm taking let's say NaCl, and I'm mixing let's say copper sulfate in that, right? So NaCl plus copper sulfate will be called as the components of the mixture, and I can take them in any ratio. I can take them in the ratio, let's say I'll take 2 grams of NaCl and I can take 5 grams of copper sulfate, or I can change it to 10 grams of this and 100 grams of copper sulfate, and so on and so forth. That means it depends upon the person, how much ever the composition it can be, he or she can keep. So mixtures have got variable composition, and the various components of the constituents of a mixture are called as the components, right? So that was the point. Let's go to the next one, the pure substances. So pure substances means you have all the constituents of the same type. For example, you have let's take, you have taken any pure substance like copper sulfate. So copper sulfate is just going to be copper sulfate, you know. Then you have gold, for example. So in the case of gold, what are you going to have? Gold means you will have just gold atoms in that. So it's a pure substance. Or anything like water. Water is also a pure substance. So if you take water matter, it will have all the molecules which will be of H2O only, right? So now further mixtures can be divided into two types: homogeneous and heterogeneous mixtures. So in homogeneous mixtures, there will be a uniform distribution, whereas in heterogeneous mixture there will be non-uniform distribution. Like for example, we'll take the example of air. So air is a homogeneous mixture of various components like oxygen and nitrogen, plus water vapor, plus other gases. So this is going to be a uniform composition. That means whichever sample of air you take, it will have the same composition of all the components. Heterogeneous mixture, of course, it indicates that the composition is not uniform, and it can have, different composition throughout. Then pure substances can also be divided into two types: elements and compounds. So elements again will be made up of only one type of atoms, whereas compounds will be made up of more than one type of atoms. Let's see some of the points from here. So just begin with this. So yes, the particles of components of the mixture are uniformly distributed throughout the bulk of the mixture, and its composition is uniform throughout. For example, there's a good example given here: sugar solution. You will see that the sugar solution is going to have sugar in the same percentage throughout. Air is also homogeneous mixture. Then in heterogeneous mixture, you will have the composition which is not going to be uniform, and example of that will be mixture of salt and sugar. So mixture of salt and sugar, that means not in the form of solid salt and sugar. So if you just mix salt 2 spoons and sugar 3 spoons, let's say, and you just mix it up, it's not that it's going to be uniformly distributed, but definitely if you just mix them in water, it will become a homogeneous mixture, right? Similarly, when we are seeing the various grains like rice and jowar, bajra, etc., it contains some amount of stones also. Small dirt is there, or some stone pieces are there. So are they uniformly distributed? Of course not. So that again is a heterogeneous mixture. So there are so many examples like that. So a mixture, there's a second point, that mixture, you can separate it. For example, if I have asked you to clean the rice which is containing some pieces of stone, you can just hand pick it. You can just remove the dirt from the rice by washing it in the stream of water, flowing water, running water. That means there are certain physical methods which are available by which we can remove the components, separate the components of a mixture, like simple hand picking, or you can say filtration. For example, I want to filter tea, so that the tea leaves can be separated from the tea. So I can do it by filtration. I can use crystallization technique, in which crystals are formed. I can use boiling methods like distillation, etc. So the separation is possible in the case of mixtures by physical methods. But now when you talk about the pure substances, as we have discussed, they have got a fixed composition. That means it will be always fixed. Like for example, H2O, you will have the ratio of hydrogen is to oxygen always 2:1. Carbon dioxide, the ratio of carbon is to oxygen will always be how much? 1:2, and so on. That means it's going to be fixed. You cannot change it. Like copper will be pure, silver is pure because it contains just one kind of atoms. Gold is again going to be pure because it just contains one kind of water atoms, water, glucose. So anything, which you just pick it up, it just should contain one type of substance. Like it can be an atom, or it can be a molecule, right? For example, copper is going to be an atom, silver is going to be an atom, gold is going to be an atom, water is not going to be an atom, it is going to be a molecule. Glucose is also going to be a molecule. So these are some of the examples of pure substances which will have a fixed composition. Then we can also say that we cannot separate the components of pure substance, right, by physical methods. Like for example, we had taken the mixture, we were talking about rice containing stones, so we could separate it by a simple method. Salt and water, like we have mixed, so can you separate them by boiling? You can separate them by crystallization technique. You can separate the salt and the water, but you cannot separate the molecules, like You cannot separate carbon, hydrogen and oxygen from the formula of glucose simply by the physical methods. So if you want to separate the constituents of any pure substance, you will have to use some chemical methods. So simple physical method cannot be employed for separation of various constituents of a pure substance. Then pure substances can be further divided into two types, elements and compounds. So here I'll just give you some good examples of elements. Like almost 118 elements are known in the periodic table. So elements will just contain one type of atom. Whereas if you talk about the compounds, so compounds will be having different atoms, right? So particles of an element consist of only one type of atoms, and they can be atoms or molecules. For example, one example I'll give you, like oxygen. So oxygen element means it contains oxygen molecules. Hydrogen element means it contains hydrogen molecules. Sodium element means it contains sodium atoms. So what is the difference between atom and molecule? When I'm saying that atom will consist of only one entity, whereas molecules will contain group of entities, right? So those group of entities can be it can be two, it can be three, it can be 4, 5, 6, 7, etc., etc. For example, sulfur element, so it is how many? 8 entities are there. So it is not an atom of sulfur, it is a molecule of sulfur. But since it is just sulfur, we'll say it is an element of sulfur. So I'm sure you've understood this point. Now so I think just let me see what else we're going to cover up here. So now in this diagrammatical representation, I'm sure you will understand that these are the atoms of different elements. Look at this: hydrogen atom, oxygen atom, nitrogen atom, copper atom, sodium atom. So all of them are different in terms of their physical properties and their chemical properties. Physical properties like their mass, their density, and then we talk about the chemical properties like their let's say boiling point of that particular substance, the melting point, some refractive index, etc., etc. So now when two atoms or more than two atoms combine together, we get a bunch of atoms. So this group of atoms is called molecule. So we have got hydrogen atoms combining together to give hydrogen molecule. We have the oxygen atoms combining together to give you the oxygen molecule. So when two or more atoms of different elements combine together in definite ratio, a molecule of a compound is formed. So this point should be very clear, students, in your mind. What is the meaning of molecule of an element and molecule of a compound. So I'll just explain finally about the difference between the molecule of an element and molecule of a compound. So molecule can be of an element or it can be of a compound, right? So in front of you on the screen, you can see we have this molecule. That means, what is molecule? It is a group of atoms. It's generally a group of atoms. It can be a single atom also sometimes, like for example helium. So helium atom never combines with another helium atom. So all the noble gases are going to be just monoatomic molecules. So molecules can be group of atoms. Sometimes they can be monoatomic also. If they are made up of only one type of atom, it is called element. But if they are made up of different kinds of atoms, it is called compound. So this point should be remembered, and I am sure you have understood this topic today. We have covered today the small topics like states of matter, and the second was classification of matter. And this table which I have told you is quite important. Please go through this. How we classify the matter into mixtures and pure substances. Mixtures have variable composition, can be separated by physical methods like hand picking, filtration, distillation. And pure substances are going to be having the fixed composition. They cannot be separated by the physical techniques. Mixtures can be having homogeneous, uniform composition, heterogeneous, having different composition. Pure substances can be elements, that means made up of only one type of atoms. They can be compounds, that means made up of different kinds of atoms. So with this, we'll just end this session, and next lecture will continue with the next topic. So till then, you keep studying, work hard, and go through all the NCERT exercises also, so that you fare good, very good in the board examinations and your coming examinations. All the best. Thank you so much. Goodbye.